Let's see the exercise 14a, that is indefinite integration. Indefinite integration. Right. Question number 37. So it is I equal to integration of under root of e raised to x minus 4 into dx. So put here under root of e raised to x minus 4 equal to t. Now squaring both sides, what will happen? See, squaring both sides. So it will become e raised to x minus 4 equal to t square, right? So take this 4 on right hand side, then it will become e raised to x is equal to t square plus 4, right? Now differentiate it with respect to x, then it will become e raised to x is equal to 2t into dt by dx is equal to constant is 0, right? So take dx on left hand side and e raised to x on right, then it will become dx is equal to 2t dt upon e raised to x, right? And instead of e raised to x, what we can write from here? T raised to 4 t square plus 4, right? Then it will be 2t dt upon t square plus 4, right? So instead of dx, you can put that. So it will be I equal to integration t into dx is 2t dt upon t square plus 4, right? Take 2 outside, then it will be t square dt upon t square plus 4. So see here, 2, it is t square, right? So add plus 4 and subtract minus 4. Why it is so? Because here plus 4 is on the denominator. That's why we have added and subtracted by 4 divided by t square plus 4 into dt. Right, now divide separately in the next step. So it will be I equal to 2 integration t square plus 4 divided by t square plus 4 into dt minus of integration 4 dt upon t square plus 4, right? So this will get cancelled. So remaining is 2 integration dt minus of 4 integration dt. And this can be written in the form of t square plus 2 square. So I will use this formula dx upon x square plus a square. So its answer is 1 upon a tan inverse x upon a. So this is the answer for it, right? So your now final answer is I equal to 2. Integration of dt is nothing but it is t minus of 4, right? So it will become 1 upon 2, right? And it will be tan inverse of t upon 2. Now put the value of t, I equal to 2. So your t, you can see on the back side slide, that is under root of e raised to 4 plus minus 4, right? So it is under root of e raised to 4, e raised to x minus 4. This will be 2 tan inverse of under root of e raised to x minus of 4 divided by 2. So this is the answer for integration plus c. So please write up to this point. Have you understood now? And here there is one mistake I have done. So 2 will be multiplied with this term, second term also now. So multiply here 2, right? I have left here. This 2 will be multiplied with this term and this term also. So this 4 will become 8. Right, so I have multiplied here. So your final answer will become 2 under root of e raised to x minus 4 minus of 4 tan inverse of under root of e raised to x minus 4 divided by 2 plus of c. Right, so this is the final answer. Understood now? So let's see the question number 39. So it is I equal to integration 0 to pi by 2 under root of cos x minus of cos cube x into it is sec square x minus 1 into cos square x into dx. So it is 0 to pi by 2, right? So take cos x common, then it will be cos of x into 1 minus cos square of x into tan square x minus 1 will become sec square x minus 1 become tan square x now. So it is equal to integration into tan square x into cos square x into dx. Now see here, integration 0 to pi by 2. So it will be cos of x under root sin square x. So this will be reduced to sin square x into tan square x into cos square x into dx, right? Now write tan in sin and cos, then it will become integration 0 to pi by 2 under root of cos x. So sin will be coming out, right? So it will be sin of x into, so it will become sin square x upon cos square. I have written tan in the form of sin and cos into cos square of x into dx. So see here, this will be get cancelled by this term. Understood? Remaining is integration 0 to pi by 2 under root of cos of x into sin of x into. So sin square I can write as 1 minus cos square of x into dx. Right. Now put the cos x as t. So cos x is equal to t. Differentiate it, you will get minus of sin of x into dx is equal to dt. When we are putting, we have to change the limit also. So put x is equal to 0 because lower limit is 0 here. So cos of 0 is nothing but it is 1. So t value we have got as 1. When we put x equal to pi by 2, then it will become cos of pi by 2 equal to t. So cos pi by 2 is nothing but it is 0. So your quotient will be reduced to 0, reduced from 1 to 0. Limits we have changed, right? So cos we have put as a t. So it will be under root of t into dx. Sin x into dx is nothing but it is your dt. So write this two term as dt with minus sign. Right, 1 minus t square. So next step will be minus integration 1 to 0 under root of t into 1 minus t square into dt. Have you understood up to this point? Sir. Okay. Now see here. So now multiply this under root t with this and this term. Then it will be minus of integration 1 to 0. This power is 1 upon 2. So it will be t raised to half minus. When we add t square into t raised to half, then it will be t raised to 5 by 2, right? Power is added by the index law. Then it is t raised to 5 by 2 into dt, right? Minus integration 1 to 0. T raised to half dt. This minus and minus will become plus t raised to 5 by 2 integration dt. So in integration, we will apply the power formula. As we know, x raised to n dx is equal to x raised to n plus 1 by n plus 1. So this is the answer for it. So it will be minus of t raised to. When we add 1, then it will become 3 by 2 and power is divided. And plus t raised to 7 by 2 divided by 7 by 2. Now put the limit 0 and 1. So it is 0, 1 to 0. So it is 1 to 0 and 1 to 0. So first time when we are putting 0, then you will get 0. Every term will become 0, right? Now put 1, then it will be minus of 2 by 3 plus 1 power, anything raised to 1 is 1 only. So it is 2 by 7. Now take the LCM. So it is 21. So it is minus of 14 plus 6. Then it will be minus of 8 upon 21. So this is the answer for it. Understood? And this is subtracted. So it will be minus minus plus. So it will become plus finally. So right up to this point now.